Hello friends, welcome to my channel MathAlcoholic. So this video is going to be the concluding video of exercise 3.1 of the chapter Matrices. Here I will be solving the last 3 questions, out of which all are objective. So as you know that I prefer to solve the objective questions in an objective approach, but I slightly give a touch to the subjective approach as well. So let us start without any delay. The 8th question is damn easy. It is said that A is a matrix Aij, which is in the order of m cross n, and it is a square matrix. If see, matrix is a square matrix only if the number of rows are same as the number of columns. So if there are 3 rows, there should have to be 3 columns. If there are 4 rows, there have to be 4 columns. So clearly the number of rows, which is m, and the number of columns, that is n, must be equal. So C is the correct option. It is by definition. I need not to elaborate so much. Now coming to question number 9. Which of the given values of x and y makes the following pair of matrices equal? So see, for this matrices to be equal, 3x plus 7 must be equal to 0. Okay, let us take it. 5 must be equal to y minus 2, equal to 5. Y plus 1 must be equal to 8. Y plus 1 must be equal to 8. And 2 minus 3x must be equal to 4. So 2 minus 3x must be equal to 4. Now see from here that the value of y from both these equations comes out to be 7, which is alright. Okay, now from these 2 equations, from one equation value of x is coming to be minus 7 by 3, and from the other equation the value of x is coming to be minus 2 by 3. Since the value of x required to make the equation satisfied is different in both the cases, that means you need a different value of x each to satisfy these 2 elements. Hence there are no possible combinations. Okay, since the value of x varies, there is no one value of x which can satisfy the equation. You can put 7 by 3 and it will not satisfy 2 minus 3x equal to 4, and either you can put x is equal to minus 2 by 3, which will not be satisfying 3x plus 7 is equal to 0. So since there is such kind of discrepancy, even though the value of y is same, 2 matrices are equal only if all the corresponding elements are equal in both the matrices. So it is not possible to find a matrix which satisfies this x and y with a single value. Okay, there are no matrices. In other words, there are no values x and y which can make these 2 matrices equal. Okay, so we are done with the 9th question. Now coming to question number 10, it is a bit knowledgeable. You need to have a very stern sense of logic to approach it. The number of all possible matrices of order 3 into 3 with each entry 0 or 1. So see, we have a 3 into 3 matrix. We have a 3 into 3 matrix. How many matrices are possible where the entry will be either 0 or 1? So see, in each of the places there are 2 possibilities. So suppose I am filling by the number of rows. I am filling 1 by 1. You can fill it in any order as possible, in any order as you wish. I am starting from here. Suppose you want to fill in here. So there are 2 possible options. Okay, corresponding to that, filling this, you have 2 possible options. Once again, once you have filled this, corresponding to this 2, you have once again 2 possible options, 0 or 1. In this way you have 2 raised to the power 9 possible combinations, okay, to fill this matrix either with 0 or 1. Fill this matrix either with 0 or 1. Okay, because for each of your choices, in the next element you have to fill either 0 or 1. So for each choice you have once again 2 choices, either 0 or 1 to fill. So each box has 2 possibilities to fill it, and correspondingly you can find that there are 2 raised to the power 9 possible matrices that you can build by combinatorics. Okay, so I think this is pretty simple. If you need further explanation, which I think you don't need, so 2 raised to the power 9 corresponds to 512, and D is the correct option. If you are not getting it, let me make you understand once again. there are 9 total boxes which you need to fill, 9 total elements. Now for each element for filling each element you have 2 options, either 0 or 1. So corresponding to one filling, there will be once again 0 or 1, your wish. In the second place, corresponding to which you are going to have once again 2 options, 0 or 1 in the third place. So in this way, for all the 9 gaps, you are getting 2 raised to the power 9 options to fill. So the number of all possible matrix is 2 raised to the power 9, that is 512. So this ends exercise 3.1. I hope you have no doubt. If you have any kind of doubt, please feel free to use the comment section. My next video, I'll be starting exercise 3.2. I hope you enjoyed that video. Thank you very much for watching this video.